Now let's look at a complicated problem in which you are investing 50% of your money to buy stock A shares and the remaining 50% of your money to buy stock B shares. These are the weights, 50% and 50%. They're already given. Then let's look at the same exact information that we had on one of the earlier slides in this chapter, where we were comparing stock A and stock B. So we have three states of the economy: boom, normal, recession. The probabilities of them are 20%, 50%, and 30% respectively. The return on stock A stock, on firm A stock, is 30% in boom, 12% in normal, minus 10% in recession, and the return on stock B is minus 5% in boom, 7% in normal, 15% in recession. Earlier, we calculated the expected return for A and B. For stock A, the expected return was 9%. For stock B, the expected return was 7%. Okay, so we want to calculate the portfolio return, expected return on the portfolio, expected variance of portfolio returns, and expected standard deviation of portfolio returns. The same exact things we were calculating for a single stock. Now, we are not buying a single stock. We are buying two stocks from two different companies, A and B. Here's how we can approach this problem. We can add an extra column to this table in which for each state of the economy, we are calculating the return on the entire portfolio. How are we going to do that? So we can do the following. If we bought just stock A, we would get a 30% return in boom. But we don't spend all 100% of our money into stock A purchase, only 50%. So we're going to earn 50% of 30%. Then we don't spend all of our money on stock B either. So we're not going to lose 5%, but because we only invest half of our money, we're going to lose half of 5%. So we have 0.5 times 0.30, that's for stock A, plus 0.5 times negative 0.05. That's for stock B. And this gives us 12.5%. That's the return from both A and B, the entire portfolio, in the boom state of the economy, if the boom state occurs, if the first row in this table occurs. The same way we can calculate the portfolio return in the normal state. So half of our money will increase by 12%. And half of our money, so by half I'm referring to the weights of A and B that are given in red, but half of our money is going to increase by 7%. So mathematically we have 0.5 times 0.12 plus 0.5 times 0.07 equals 9.5%, right? So we are going to increase our money by overall 9.5% if the normal state of the economy is what takes place. And then if instead the recession is what actually occurs, then we are going to make a 2.5% return on our portfolio, which is calculated by multiplying 0.5, the weight of stock A, by minus 0.1, the return on stock A in recession, plus the weight of stock B, 50%, times the return of stock B, 0.15, in the recession state. Okay, so if you look at this column that we have just created, we have 12.5% in boom, 9.5% in normal, 2.5% in recession. These are the three possible returns on the portfolio. Now treat these three possible returns as your new starting point. How would you calculate their expected return? Same as what we were doing for a single stock on one of the earlier slides, or on many of the earlier slides, right? We had several examples. We take the probability 20% of the boom state and multiply by 12.5% return on the portfolio in the boom state, plus the probability of the normal state multiplied by the return on the portfolio in the normal state, plus the probability of the recession state, 30%, multiplied by 2.5%, or in decimals 0.025, the return on the portfolio in the recession state. The sum of these three products gives us an 8% expected portfolio return. This is one way you could calculate portfolio expected return. There is a completely different way. Remember, earlier we already calculated that the expected return on just stock A is 9%, and the expected return if you just buy stock B is 7%. Because you're buying them like equally with your money, so half of your money buys A, half of your money buys B, then intuitively it makes sense to say that overall your expected return on A and B combined will be halfway between 9% and 7%. In other words, the math you could do instead is take the weight of stock A, 50%, and multiply by the expected return on stock A, 9%. And then add the weight of stock B, 50% in our problem, multiplied by the expected return on stock B, which is 7%. This calculation again gives you an 8% expected return on the portfolio. So there are two ways of doing the calculations. It doesn't matter which one you do. Both require the same amount of work. Even though the second method seems much faster, keep in mind that we are not given the 9% and the 7% expected returns on A and B. You have to calculate them first. So whichever way you do it, you will be doing the same amount of work. So it's just whichever method you find more intuitive. Although I would like to add that you do need to understand both, because there are some problems in which you have to use the second method, because based on what's given, you are already given the expected returns on the individual stocks in your portfolio. In that case, you have to use the second method. So keep in mind that, both methods should be equally, understood by you. Next, let's calculate the expected variance, sigma squared, and the expected standard deviation, sigma, of this portfolio. Because we are treating the portfolio returns in boom, normal, and recession as if it's just, a fresh problem for some one asset, we can apply the same exact formulas as we used for a single stock in earlier slides. So we do the probability of the boom state, 0.2, multiplied by the return on the portfolio in the boom state, 12.5%, minus portfolio expected return, 8%, that we have just calculated on the last slide. And then we square that deviation from 8%. Then we add the same thing, probability times the squared deviation for the portfolio in the normal state, and then the same thing one last time for the recession state. This gives us the portfolio expected variance. In decimals, it's 0.001425. The square root of that is the portfolio expected standard deviation of returns, which is in decimals 0.0377 or 3.77%. How would we summarize the information we obtained on this portfolio? We can say that if you buy both company stocks in equal dollar amounts, right, stock A and stock B shares in equal total dollar amounts, then you expect to grow your investment by 8% every year in the future. However, your actual portfolio returns will be fluctuating. They will not be 8%, as a stable increase per year. They're actually going to be fluctuating around 8% average growth by, on average, 3.77% in either direction, either above 8% or below 8% by 3.77% on average. There's another thing you may notice in this last problem. The portfolio fluctuations or risk was 3.77%, right? However, for the individual stocks A and B, like we saw, let's see where we saw it. We saw it slide 24. The standard deviations of the two individual stocks A and B were both above the portfolio standard deviation. And this should kind of look very strange, right, at a first glance. Like, why wouldn't portfolio risk be also halfway between the individual stocks risk levels, just like we saw with the expected returns? Well, this is something strange that happens, and there is actually an explanation for it. We call it the diversification effect. It doesn't always happen, but in the example we looked at, it's very, very obvious. The idea is, let me just go back to what we were given. Let's say here, slide 30. Do we ever lose money if we buy just stock A? All of our money is spent on stock A. Yes, we may lose 10% of our money if the so-called recession outcome takes place. Can we lose money if we just buy stock B? Again, the answer is yes. We can lose 5%. Every now and then, there's a 20% chance of losing 5%, like 1 in 5 years, if the boom year occurs. Now, my third question is, can you lose money if you buy both A and B? Well, let's look at the portfolio returns. 12.5%, 9.5%, 2.5%. No, we can never lose money. That's great, right? So why can we never lose money? And why do we get... Okay, so let me just answer this question. Why can we never lose money? Look at what has happened. Whenever we would be losing money on stock A, we're going to be offsetting the loss with stock B gain, right? We're never going to lose 10% because even though half of our money loses 10%, the other half makes 5%, right? Then we're never going to lose money in the boom state because even though half of our money loses 5% from stock B return, the other half of our money would gain 30%. So the losses are always offset by the gains, right? In all, individual states of the economy. That's what we mean by this diversification effect, right? It's good to buy stocks with returns that are sort of inversely related. Whenever the return is low on one stock, it's high for the other stock. For example, in the boom state, the return is negative for B, but very high in A, highly positive. And in the recession state, the return is negative for stock A, but it's positive and very high for stock B. So A and B are kind of helping each other. They're offsetting each other's losses with the gains. And this is why we're never going to have this wide range of returns that we see for stock A or for stock B. The portfolio returns are going to be sort of much closer together, resulting in no possible loss ever. That's the diversification effect.